In this video, we are going to learn preposition 2.4. We know that the legendary symbol is denoted by A with respect to P. In this preposition, it states that 2 with respect to P equals minus 1 the whole raised to P square minus 1 by 8. And it takes the value 1 if P is congruent to plus or minus 1 mod 8. And it takes the value minus 1 if P congruent to plus or minus 3 mod 8. Here note that P is an odd prime, that is P is a prime which is greater than 2. So if I take the value P equals 11, we know that 11 is congruent to 3 mod 8. Therefore, 2 by P takes the value minus 1 if P equals 11. If I take the value P equals 7, we know that 7 is congruent to minus 1 mod 8. Therefore, 2 by P takes the value 1. Now, coming to the proof. First, we define f of n is equal to minus 1 the whole raised to n square minus 1 by 8 if n is odd, and f of n equals 0 if n is even. We shall show that 2 by p equals f of p. And what is f of p? It is minus 1 the whole raised to p square minus 1 by 8. That is what we have to show in the preposition. So we shall show that 2 by p equals f of p. We know that for any odd prime p square congruent to 1 mod 8. If I take p equals 3, 3 square is 9, 9 is congruent to 1 mod 8. If I take p equals 5, 5 square is 25, 25 is congruent to 1 mod 8. If I take the value p equals 11, 11 square is 121, and 121 is congruent to 1 mod 8. So, p square congruent to 1 mod 8 is generally true for any odd prime p. Therefore, by definition of congruence, I can write 8 divides p square minus 1. In preposition 2.1, we have learned the field fq has a primitive nth root of unity if and only if n divides q minus 1. Here we have n equals 8 and instead of q we have p square. So by this preposition, we can write the field fp square contains a primitive 8th root of unity. Now, let xi element of fp square denote a primitive 8th root of unity. That is, I'm going to take an element xi from the field fp square and it denotes a primitive 8th root of unity. Then I can write xi raised to 8 equals 1 by definition of nth root of unity. By taking square roots on both sides, I get xi raised to 4 equals plus or minus 1. But can I write xi raised to 4 equals 1? No, because by definition of primitive nth root of unity, xi is a primitive nth root of unity if xi raised to n equals 1 and xi raised to m not equal to 1, where m lies between 0 and n. Okay, so here we can see that 4 lies between 0 and 8. Therefore, xi raised to 4 is not equal to 1. I can write only as xi raised to 8 equals 1. Then the only remaining possibility is xi raised to 4 is equals minus 1. So I got xi raised to 4 equals minus 1. Now I define the Gauss sum. You will learn about Gauss sum in the next preposition 2.5. But for the time being, I am defining the Gauss sum. G is equal to sigma j is equal to 0 to 7 f of j into xi raised to j. Why did I define j from 0 to 7? Because in Gauss sum, it is defined from j is equal to 0 to n minus 1. And what is n? N is 8. So I defined from 0 to 8 minus 1 equals 7. So g is equal to sigma j is equal to 0 to 7 f of j into xi raised to j. When j is even, f of j is 0. Because by definition, we have defined that f of n is 0 for n even. So we will take the odd numbers for j, that is 1, 3, 5 and 7. Then the Gauss sum g equals f of 1 into xi raised to 1 plus f of 3 into xi raised to 3 plus f of 5 into xi raised to 5 plus f of 7 into xi raised to 7. What is f of 1? F of 1 is minus 1 the whole raised to 1 square minus 1 by 8, that is minus 1 the whole raised to 0, that is 1. So f of 1 is 1. What is f of 3? F of 3 is minus 1 the whole raised to 3 square minus 1 by 8, that is minus 1 the whole raised to 1. So we get f of 3 is minus 1. Similarly, f of 5 is minus 1 and f of 7 is 1. Substituting these values, we get g equals xi minus xi cube minus xi raised to 5 plus xi raised to 7. Now we can write xi raised to 5 as xi raised to 4 into xi and xi raised to 7 as xi raised to 4 into xi cube. We know that the value of xi raised to 4 is minus 1. So in the next step, we get g equals xi minus xi cube plus xi minus xi cube. That is 2 times xi minus xi cube. Now we are going to find g square. G square equals 4 times xi minus xi cube the whole square. That is equal to 4 times xi square minus 2 into xi raised to 4 plus xi raised to 6. We can write xi raised to 6 as xi raised to 4 into xi square. And the value of xi raised to 4 is minus 1. So g square becomes 4 times xi square plus 2 minus xi square. Now we cancel xi square and minus xi square. Thus we get g square equals 8. Now we are going to find g raised to p. We can write g raised to p as g raised to p minus 1 into g. Now I am going to multiply and divide 2 to the power p minus 1. So it becomes g raised to 2 times p minus 1 by 2 into g. We can rewrite it as g square the whole raised to p minus 1 by 2 into g. What is g square? We know it is 8. So we can write 8 raised to p minus 1 by 2 into g. Now by proposition 2.2, we learned that a by p is congruent to a raised to p minus 1 by 2 mod p. So we can write 8 raised to p minus 1 by 2 as 8 by p. Now in the next step, I am writing 8 by p as 2 into 2 square by p. By proposition 2.3 property C, if b is prime to p, we can write ab square by p equals a by p. Okay, so in 2 into 2 square by p, we can see that here b equals 2. And the GCD of 2 comma the prime number p is 1. So 2 is prime to p. Therefore, we can write 2 into 2 square by p as 2 by p from this proposition. Therefore, g raised to p is 2 by p into g. Now, we are going to find g raised to p using another method, and that is by using a lemma. The lemma states that in any field of characteristic p, a plus b the whole raised to p equals a raised to p plus b raised to p. And this lemma is right after proposition 1.4 in the text. Now, f of j the whole raised to p equals f of j for any odd prime p. So let us check that. I am taking the value j equals 5. So, and we know that f of 5 equals minus 1. Let p equal to 7. P is an odd prime. Let p equal to 7. So, f of 5 the whole raised to 7. What it is? It is minus 1 the whole raised to 7. And minus 1 the whole raised to 7 is minus 1. And that equals f of 5. So, we got f of j the whole raised to p equals f of j. And this is generally true for any odd prime p. Okay. Then I can write g raised to p equals sigma j is equal to 0 to 7 f of j into xi raised to j the whole raised to p. Now, since a plus b the whole raised to p is equal to a raised to p plus b raised to p, I am taking the power p inside, and I can write sigma j is equal to 0 to 7 f of j the whole raised to p into xi raised to jp. And what is f of j the whole raised to p? It is f of j. Okay. So I can write sigma j is equal to 0 to 7 f of j into psi raised to jp. Now I am writing f of j as f of p into f of jp. Why? Because what is f of p into f of jp? By definition, we can write it is minus 1 the whole raised to p square minus 1 by 8 into what is f of jp? Minus 1 the whole raised to j square p square minus 1 by 8. Now, initially we saw that p square is congruent to 1 mod 8 for any odd prime p. So I can write, when I substitute p square equal to 1, I can write minus 1 the whole raised to 1 minus 1 is 0. So 0 by 8 is again 0. Minus 1 the whole raised to 0 into, when I give p square equals 1, again minus 1 the whole raised to j square minus 1 by 8. Now minus 1 the whole raised to 0 is 1. So I can write minus 1 the whole raised to j square minus 1 by 8. And by definition, this is f of j. Now, changing the variable jp as j dash, from this step, we obtain g raised to p equals sigma j dash is equal to 0 to 7 f of p into f of j dash into xi raised to j dash, because we changed the variable jp as j dash. Taking f of p outside, we get g raised to p equals f of p into sigma j dash is equal to 0 to 7 f of j dash into xi raised to j dash. And what is sigma j dash is equal to 0 to 7 f of j dash into xi raised to j dash? It is Gauss sum. Therefore, g raised to p is equal to f of p into g. And I mark this as equation number 2. Now, what was equation number 1? It was g raised to p is equal to 2 by p into g. And what is equation number 2? It is g raised to p is equal to f of p into g. So comparing 1 and 2, we get 2 by p is equal to f of p. And what is f of p? It is minus 1 the whole raised to p square minus 1 by 8. And that was our proposition. So hence we have proved the proposition. Thank you.